Hi students, welcome to my lectures on chemical engineering thermodynamics. Please follow my lectures from the beginning because every lecture is connected. And in today's lecture, we are going to discuss about bubble points and dew points of a mixture. See, we have to deal with the solutions. If it could be gas mixtures or liquid solutions, because our first agenda is to separate the components and purify the components either by evaporations or condensations. And if we can able to bring the vapor liquid equilibrium, that means if we can able to get the vapor as well as a liquid at the same temperatures and pressures, we can able to achieve this separation or purification. Yes, that is why it is called vapor liquid equilibrium process. So we know about the pure components. Example, we always know the water will evaporate at liquid water will evaporate at 100 degrees centigrade at 1 bar pressure or 1 atmosphere pressure. Same, if I have the vapor at 100 degrees centigrade at 1 bar, if I remove the heat, it will condense the temperature at 100 degrees centigrade. That means simultaneously we can evaporate the water at 100 degrees centigrade by providing the heat, and we can condense the water vapor at 100 degrees centigrade by removing the heat. That means the boiling point and condensation point of water, example, it is at 100 degrees centigrade. Okay. Then what happens if I have more than one component in the liquid? Okay, if you have more than one component in the liquid, then the things changes. Let us say I have A and B in the mixture. If I start producing the vapor, okay, the evaporation temperature, example, let us say it is A plus B mixture, the evaporation temperature is at 100 degrees centigrade. And if I have A plus B mixture in the vapor, the condensation temperature may not be at 100 degrees centigrade. For pure components, 100 degrees, for example, water can evaporate in 100 and the water can condense at 100. That means boiling point and condensation point for the pure pure components will be the same. But mixture, the boiling happens at one temperature, the condensation happens at another temperature. There is always difference between the boiling point and condensation point. That is why we should know at what point the evaporation happens, at what point the condensation happens. You know, evaporations and condensations depends on the temperatures and pressures. So it is our primary objective to find out this evaporation temperatures and condensation temperatures, or evaporation pressures, condensation pressures. Technically, these things are known as bubble points and dew points. Okay, that is what today's discussion is about, the at what temperature the bubbling happens, at what temperature the condensation or dew happens. Okay, so that is why the today's lecture is finding out bubble P, dew P, bubble T and dew T. A small introduction. The detailed calculations we are going to learn in the subsequent lectures. What is bubble P? BUBL, that is bubble point. Okay. What is dew P? Dew point. P representing the pressure. That means in this bubble P, we have to find out at what pressure the vaporization, the bubbling point can happen. What is dew P? If you have a vapor, at what pressure conditions you have some dew, condensation point will occur. Bubble T, at what point, at what temperature the liquid mixture starts bubbling. Okay. Dew point temperature, that means if you have a vapor, at what point the condensation, that droplet will form, that is condensation will form. Okay. For pure mixtures, the bubbling points and dew points are same. Okay, that means at specific temperatures pressures will be the same. But for mixtures which we have to deal in the industries, the bubbling points will be different, dew point will be different. Okay, that is what today's lecture. And schematically I have represented these things so that you can understand and connect with it. Example, I have some container with me. Okay, let us discuss about the bubble P. That means bubble point pressure. At what pressure the bubble will form in the mixture. That is what the bubble point pressure at a given temperature. Okay, bubble point, you can see the bubble I have represented with the round, kind of bubble here, because there is a mixture consisting of A and B. Okay, which is in the liquid. The entire container is filled with a liquid. For example, you start heating the liquid. What happens at one point of time, these bubbles start appearing. That means vapor is going to form. Then you have, your objective is to find out if bubbling happens, bubbling inside the vapor will be there. At what pressure this bubble is going to form. If bubble is forming, what is the fraction of A in the bubble, what is the fraction of B in the bubble? Inside the bubble, vapor will be there. So whenever you get to finding the bubble points, what is given and what you have to find P, okay, YA, YB, because bubble point pressure, that means pressure you have to find, that means P, okay, and YA, inside the bubble what it is going to be there, vapor. In vapor, what is important? Fraction of A in the vapor, fraction of B in the vapor. That means in the bubble point, your objective is to find out bubble point pressure and YA, fraction of A in the bubble, fraction of B in the bubble. Okay, at a given temperature, that means temperature will be provided because your objective is to find out the pressure. So the temperature of this mixture is given, XA and XB. That means fraction of A in the liquid will be given, fraction of B in the liquid will be given. Our objective is separations and purification. So obviously you have to find out for a given fraction of A in the liquid and given fraction of B in the liquid, how much A will be in the vapor and how much B in the vapor, and what is the bubble point pressure, at what conditions this is going to happen. Similarly, dew point, understand this. If you want to find out the dew point, that means at what pressure the first droplet will come from the vapor. That means there will be the mixture in the container consisting of A plus B in the vapor, which is fraction is YA and YB. When the first bubble forms, for example, inside the bubble the liquid will be there. In the liquid, what is the fraction of A in the liquid and fraction of B in the liquid? So this is what the dew point pressure. At what pressure this bubble will, this droplet will form. In this droplet, what is the amount of A and B is present. Then whenever you see the dew point calculations, what is given and what is you have to find. Of course, dew P you have to find, that means pressure, bubble point pressure, dew point pressure you are supposed to calculate. So pressure, the bubble will form, right? The droplet will form, right? In the droplet, what it is going to be there? What is the fraction of A in the liquid? What is the fraction of B in this liquid? That means you have to find P, XA, XB given temperature, YA and YB. Okay, this is how you have to interpret. So similarly, these first two things talks about the finding of the pressures at a given temperature. So next two things will be finding out the temperatures at a given pressures. Example, what is the bubble point temperature? That means, of course, temperature you have to find. At what temperature the first bubble is going to form. So there will be initially liquid in the container consisting of A and B. So a bubble will going to form. In the bubble, vapor will be there consisting of A and B. If what is the fraction of A is YA, fraction of B is YB. So whenever you are trying to calculate the temperatures, pressure will be provided. So what is given and what you have to find? Of course, bubble point temperature you have to find, T you have to find, okay, and what else you have to find? Bubble, inside the bubble vapor will be there. In the vapor, YA and YB you are supposed to calculate. That means temperature, YA and YB should be calculated at a given pressure, XA, XB. XA, XB means liquid fraction of A in the liquid, fraction of B in the liquid. So next is dew point temperature, okay, that means you have to find out the temperature at which the first droplet is going to form. Okay, that means initially there will be a vapor consisting of YA is a fraction of A in the vapor, fraction of B in the vapor. So you have to find out the dew point, at what temperature the first droplet is going to form. So obviously what you are supposed to find and what is given. So dew point T, temperature you have to find. Okay, T you have to find. And what else you have to find? If a droplet is going to form at this temperature, what is the fraction of A in this bubble and fraction of, in this droplet, and what is the fraction of B in this droplet? Okay, at a given pressure, YA and YB. So these are the 4 different calculations that comes specifically in vapor liquid equilibrium. So you have to be clear in what you have to find and what will be provided. So in general, these two are easy to calculate because temperature is already provided. In these two things, temperature is not provided. So some iteration procedure is you have to assume some temperatures and repeat the calculations till you converge to a solutions. So finding out the bubble T and dew T requires iterations. Here it's a straightforward calculation. So what are the equations that are required? Okay, initially we assume that vapor is also ideal, liquid is also ideal. So when vapor and liquid both are ideal, the Raoult's law is going to use. So in Raoult's law, these are the formulas you are supposed to use in finding out different in all the 4 calculations. What are the useful equations? One is, what is partial pressure of A is equal to YA into P, which is XA into PA set. Partial pressure of B is equal to YB into B, which is XB into PB set. Total pressure is nothing but partial pressure of A plus partial pressure of B. Because primarily in the lectures we are dealing with the binary solutions. So YA plus YB equal to 1, which is fraction of A plus fraction of B in the vapor will be equal to 1, and fraction of A plus fraction of B in the liquid will be equal to 1. And what else we are going to use along with the Raoult's law calculations? Antoine equations. Antoine equations used to find out the T sat and P sat. Okay, T saturated, and at given pressure what is the temperature, at given temperature what is the pressure. So these are the set of equations we are going to use in finding out all that is written on the board: bubble P, dew P, bubble T, dew T. Okay, let us find out one by one so that it will be more clear. Thank you. Let us meet with a new lecture.